Ah, I was being silly, guys. Don't know why that happens. I didn't record the first 3 questions, which is a huge pity. Okay, but don't worry. I'll post explanations for the first 3 questions on the WhatsApp group, perhaps. Well, no, there's still time to practice because you guys will still write the mock test. So we might see some similar sort of questions going on. Okay. So yeah, don't worry about that. And very sorry for not recording the first 3. Ah, silly me. Okay, this one's not too difficult because it's just relying on definitions, right? Almost definitions. Okay, but everyone splits. Okay, that's interesting. So it is service process installer. Do remember, guys, so when we added a service installer to our app, so this one was actually the hardest. I wasn't expecting that. Okay, you have seen this before. If you guys think back to the Windows Services lecture, when we added a service installer to the application, an installer to the application, it added 2 classes. It added the service installer class and it added the service process installer class. These 2 middle ones don't, well, they do exist, but they're not used for this. Okay, so they're just tricks. The 2 that were installed was the service installer and the service process installer. Okay, so the service installer will hold things that are specific to each of the services. The service process installer will hold things that are specific to the entire app. Okay, so both services in this case. There could be 3 or 4 or 5 services, right? In which case the service process installer has information like the account type that is for all of the services we're installing. And the service installer class has things that are specific to each of the 5 or 2 or 3 services we're installing. Okay, so that's the distinction you must remember. Can anyone name what are some properties that would be in the service installer class? Can anyone name in the chat what are some properties that would be in the service installer class? Does anyone know? So what are some service specific? You know, I would think Adam would remember. So what are some service specific things that went into the service installer class? Well, don't you remember when we installed our service, was there not some special thing that we set in the service installer class? So the reason I'm singling, exactly, display name. Okay, display name, precisely. Yeah, okay, so the display name, the description, the start type, those go in the service installer class. What do you notice about those things? They're all specific to a single service. If we were installing multiple services, the account property would be the same for all of the services we're installing, but each of them would have their own display name. Okay, so that's why we have the service installer and the service process installer. Oh, and it's service process installer, not service process install. Okay, so sorry about that as well. But yeah, I mean, you probably read it as service process installer anyway. Jad, cool. All right, on to the last question. So angry at myself for not recording the first 3. So silly. After we install the 2 services in the previous question, where would we view the messages that they post to the event log? So where would we go to then view all the little messages that they post to the event log? Where did we go? Guys, remember I like right-clicked on, again, never mind. I won't say any more. It's not too bad, I don't think. Clues in the name, I'll say. Okay, good. Most people got it. That's good. Yeah, so it's called the event viewer. Okay, the event viewer. And you can remember, if you just check back in the Windows Services lecture in the recording, you can see that like on the left, it says event viewer, and it's like a little drop-down list that has all of the little events that are posted. Okay, cool. Nicely done, guys. Okay, I know some of them were tough. I don't know what to do because It's okay. There was some ties, lots of ties, but yo, Halfini really, yeesh, nice. That was a big lead. Cool, nicely done. Anyway, yeah, I don't know if it updated the points as well for that one question. Cool. Good game, guys. Nicely done, everyone. Okay. Cool. We're jumping into relational databases. I'll somehow get the information that were in the first 3 questions. If you're only watching the lecture recording, I'll somehow get that information to you because it is good. The questions are definitely good for you to answer. But anyway, actually, we will be doing revision lectures before you write the test, so there's no reason to worry, actually. Anyway, cool. So relational databases. I just jumped through the introductory slide there. So a database is an organized collection of interrelated data. Okay, cool. Not too bad. So that's where we start, the formal definition. Again, that's never too helpful. There's quite a lot of topics under this whole databases thing. We're going to start with a fairly theoretical lecture so that you guys can come to grips with it a bit. Just like learning the definitions so that you can figure out what we type. But after you learn these sort of introductory bits, I think you'll be quite pleasantly surprised because SQL, so structured query language, which is the language we use to interact with databases, is actually kind of easy once you understand the theory of databases. Okay, but anyway, let's just jump in. Okay, so we have this idea of a database, which is just a collection of data, really. I mean, organized collection of interrelated data. Interrelated kind of implied, organized. Why would you want it another way? So yeah, the definition, fairly trivial. But what we actually are, yeah, exactly. So what we actually care about is relational databases, okay? There are 3 things that we need to remember about relational databases. It has to do with how we organize the data, okay? So entities, attributes, and relationships. Entities, attributes, and relationships. Okay, so those are the key things to remember. All right, just some terminology. I'm sorry, there's going to be a lot of terminology. I have made the slides very detailed. You can basically study the introductory bit of chapter 6 from the slides, but that means there's a lot of text to get through on each slide, okay? So how do we create databases? How do we manage them, store them, back them up, all of that kind of stuff? We use what are called database management systems, okay? If it's a relational database, which again, it's similar to the whole thing with JavaScript that we had back in chapter 4, was it? Where it's kind of like a bit outdated the way they speak about some things, because nowadays all database management systems are relational database management systems. In fact, like basically all databases are relational databases, except for this weird thing that Google's got going on. But anyway, so cool. So relational databases. Here, it gets slightly more interesting, I suppose. Steps for designing a relational database. I think this is the first time we've seen a set of steps that is not a cycle. So that's at least one new thing, okay? So we start by creating a mission statements, which why they said this, I don't know. Like, yes, your database needs a purpose before you create it. That's all that means. Okay, like why are we building a database is probably a good question to answer at the beginning. Okay, and then we get into something relevant. All right, so you first start by determining what your database needs to store. You divide the data into tables and columns. You choose the primary keys. So I'll say no cap. Don't know. What do you mean, Ethan? So choose the primary keys. So good time to introduce this term. So primary key, that is the item in, so it's just a table and you guys will see it later. Actually, I'll point it out later. Never mind. It means no lie about it not being a cycle. Oh yeah. So identify relationships. Again, we'll talk about this later, and normalize the database. Okay, we'll get through all of this. The big thing about this little diagram here is that these 4 middle steps can be done in like this nice graphical way. Okay, a nice graphical way, almost like it's pictures, basically. We need to learn about pictures. Okay, so entity relation modeling, that's what it's called. Okay, cool. Yeah, no problem. Cool. And we do entity relation modeling with entity relationship diagrams. Okay, so these 4 steps: determining what data we need to store, dividing the data into tables and columns, choosing primary keys, and identifying relationships can be done with pictures, which is great. Okay, so entity relationship diagrams, that's what we have to learn about now. Okay, so relational databases, as I mentioned earlier, organize their data according to 3 concepts, and they're in bold there, so you can't miss them. Okay, entities, attributes, and relationships. Now, if you think back to chapter 2 with object-oriented programming, you'll notice that actually these are very similar to ideas that we already know about. Okay, in fact, we've actually been using the same word to describe one of them, right? This word attributes, you've heard this word before, and it's very similar in this case. Okay, and you'll see that now. So entity relationship diagrams combine these 3 aspects, so entities, attributes, and relationships, and they define, they graphically represent them. Okay, they graphically represent them. All right, so how do we do this? All right, so I'm just gonna describe these 3 different things. Okay, and we'll put the little picture there so that you guys can understand it. So I've got one example here that I'm going to do here. So you can see that in the slides. There's another different example on page 145 of your textbook. Okay, and you'll notice that regardless of what we're designing a database for, these ideas can describe it effectively. Okay, which is similar to object-oriented programming in a way. Okay, so what is an entity? An entity is a concept. Okay, it's just a concept. They're described by nouns. All right, so it's just it's just something that represents a physical object or concept. Okay, so guys, can you tell me, even just from this definition, what is it in chapter 2 that is somewhat analogous to what an entity is? Do you guys remember? What did we learn about in chapter 2 that is somewhat analogous to what an entity is by this definition over here? A construct that represents a physical object or concept. What did we learn about in chapter 2 that's somewhat analogous to this idea of an entity? An entity. A class, exactly, a class. So like class publisher, you can picture that existing. Class book, you can picture that existing, right? Makes sense. In your book, there's class customer or class order. Okay, in databases, they're called entities, but they're kind of they're similar to classes, except they don't have behavior. Okay, basically. So they're focusing on data storage as opposed to actually doing things with data, but they can do things with data as well through something called procedures, but we'll discuss that later. Anyway, so, but what's a procedure? I don't know. Okay. Anyway, so the next thing. So entities, you guys kind of get what those would be. So like a publisher, book, they're representing some concept. Okay. So an attribute. Okay. An attribute, the properties that make up or define an entity. Now, I would tell you, what concept is or I would ask you, what concept is an attribute analogous to that we learned about in chapter 2? But actually, it has the same, it's the same, right? We used the word attributes to describe the thing we learned about in chapter 2. And there's a reason for that. There is a relationship here, guys. There is a relationship. So you can see inside a publisher has different attributes. They have an ID. Okay, an ID. So that's just a way to uniquely identify each publisher. Makes sense. They have names, right? Publishers have names, and they have cities, right? Where they're from. All right, cool. Makes sense. A publisher would have those attributes. They would also have other attributes as well. Each publisher has those attributes, but there's also a book. Okay, a book is another entity, right? Publishers publish books. So a book is another entity, and they also have an ISBN number, right? Like related in some loose sense. Related in some loose sense. Should we Google the formal definition? Maybe we can when we have a break. Cool, but yeah, it's like just related, okay, or even like metaphorically, something like that. Okay, so book. Cool. So books have ISBN numbers, right? Which is just a way to uniquely identify each book. They have titles and they have authors. Okay. Those are attributes that a book has. Now you can imagine inside a class called book, we might store a string called title. Okay. This is a related idea, right? There are attributes and there are books. So there's concepts, and those concepts or objects are made up of different attributes that make them unique. Okay, similar idea that we've got going here. Okay, and then we also have, and this is where it gets new. Okay, this is where it becomes slightly different. The other thing that this entity relationship diagram and relational databases allow us to define is a relationship. Okay, so that is an association between entities. So you can see, like, a publisher releases or publishes books. Okay, in your book on page 145, you can see that a customer places orders. Okay, a customer places orders, a publisher releases books. Okay, so we've got this relationship. All right. So cool, fairly straightforward. Now, what does this little 1 and n mean? Okay, there's lots of different ways of representing this in different ERDs. This is the one that they use inside your textbook and inside this course, okay? So the 1 on the one side is saying that there is one publisher, okay? The n on the other side, don't ask me why they use the letter n. The n on the other side represents many books, okay? So when we say 1 to n, what we mean is 1 to many. Okay, so one publisher publishes or releases many books. Okay, so books are defined by these concepts, publishers are defined by these attributes, and one publisher, yeah, the one on the one side, the one on the one side. yeah, okay, the one on the left, I'll say instead. But yeah, interesting wording there. Okay. But yeah, once you have this ERD diagram, you have a database, basically, or at least you have the design of a database. Obviously, what this diagram is missing is actual data, but we'll fill that in now. Okay, but this is defining the structure of our data. Okay, the structure of our database. All right, just 2 steps to convert an ERD into a database. Okay, so we've got this database here, and it's super easy to convert a database. And we've got this ERD over here, and it's super easy to convert this entity relationship diagram into a database. Okay, so the entities, so each entity, the publisher, the book, each entity will define a table. Okay, and when I say table, you'll see on the next slide, I literally just mean table, like rows and columns. Okay. And each attribute will be a column in that table. Okay, and then we just have to map the relationship. Okay, and the way we map the relationship, I'll show you on the next slide. Okay, so we've got this ERD diagram on the left here. I added just another thing to book. You can see I can add another attribute. It's easy, right? Books also have a genre. Okay, so I just showed you how easy it is to just add another attribute to this little ERD diagram. And I also just changed ISBN to ID just to make things, consistent. But yeah, ISBN, ID, whatever. Same thing for a book. Okay. So cool. We've got this little diagram on the left here, and I explained what it means, right? There's a publisher. Publishers release books. Okay. They have different IDs, so we can uniquely identify each publisher, and we can uniquely identify each book. The ID is what we call the primary key. Okay. You can tell it's the primary key because it's underlined. Okay, the primary key is always underlined. Okay, so publishers have names and cities, books have titles, authors, and genres. Okay, cool. So what do we do here? How do we turn this into a database? Like I said, it's literally just tables, guys. It's literally just a table, or multiple tables, rather. Okay, so we start by saying each entity becomes a table. Okay, so we have a publisher and we have a book. So we've got a table for publishers and a table for books. 2 tables. Why do we have 2 tables? Because we have 2 entities, right? Makes sense. Each attribute becomes a column in the table. So the publisher has 3 attributes. So that means it has 3 columns, okay? It has an ID. So publisher 1, publisher 2, publisher 3. That is the primary key. That is how we uniquely identify each publisher. Okay, so if I ask for publisher 1, you can tell me their name and city, right? Project Gutenberg, Springfield. ID 2, Infogrid Pacific, Singapore. ID 3, Penguin, New York. Okay, so we have these rows, Okay, each row is representing a specific piece of data. Okay, or rather multiple pieces of data. Okay, so what we call a record, by the way. So each row is called a record because it's recording pieces of data. Okay, cool. And we do the same thing with book, basically, with one little change. Okay, so we also have an entity called book. So we create an entity called book. Book has ID, title, author, and genre. So we have ID on the left here, book 1, book 2, book 3. Okay. We have titles for our book. The War Poems of Sigrid Sassoon, Metamorphosis, and Grimm's Fairy Tales. Okay. We have authors for our books, and we have genres for our books. Okay. Poetry, fiction, fiction. Okay. Now you guys will notice there's one little weird distinction here. What is this doing? Publisher ID. Okay. What is that doing? You notice the second step. So if I remove this, column here, that one there, if that was gone, you could see then we would just have two tables, right? We would have a publisher with an ID, a name, and a city, and we would have a book with an ID, a title, author, and genre. So that would be the book table is just defining this guy over here, and the publisher table is just defining this guy over here. Okay, we just created those two tables. This extra column here, publisher ID, that is what is defining this relationship, releases. Okay, that column ID over there. Okay, so we take the ID of the thing on the left, the one, and we put it in the table on the right, the many. Okay, so let me explain this to you a little bit easier, but it might actually be easy to see for a lot of you already. Exactly. So if I asked you guys, which publisher published Metamorphosis by Franz Kafka? Which publisher published Metamorphosis by Franz Kafka? Give me their name. Can anyone give me the name of the publisher that published Metamorphosis by Franz Kafka from our little database here? Exactly. It was Penguin. Okay. Can someone tell me what city does the publisher who published Grimm's Fairy Tales come from? What city does the publisher who published Grimm's Fairy Tales come from? Ooh, Grimm's Fairy Tales, hey? Grimm's Fairy Tales. Springfield. Okay, Springfield. Yeah, precisely. So let's see, how did we do this? It's not too bad. So we just said, all right, Grimm's Fairy Tales, that's over here. All right. The publisher ID over there, okay? Bam. Okay, that relates us back to Project Gutenberg over here. Where is Project Gutenberg city? Springfield. Okay, so that's how we read the database. That's how the relationship is defined. Why is it one to many? Well, because one publisher can publish as many books as they like, right? And you guys can see that. So I could just add another field here with another thing published by Project Gutenberg or whatever, just by putting the ID there. Okay. So, I mean, add another record, right? Like adding another row to the table. All right. But it's fairly straightforward to read. Hopefully you guys can see what this column is doing. So that's how you convert an entity relationship diagram into a database. So yeah, not too bad, hopefully. Oh, let's see. There's more messages on the chat. Same also. Yeah, that's hectic. Shame, guys. Okay, cool. Okay, so job done, right? We've learned about databases, chapter 6 over, okay? But no, okay, not quite. So there is one huge process that we haven't learned about yet called database normalization. So this thing on the right here might look okay to you. You might look at this and go, hey, that's a pretty good database. It's like relating publishers to books. Seems sensible. Yeah, job done. But actually, it's not okay, okay, for like a great number of reasons, okay? So the next process, we've done these 4 steps. That's what entity relationship diagram allowed us to do. The center 4 steps is all just done when you make that little diagram, okay? But this one extra step on the right here, normalizing the database, resolve any issues that may affect data integrity. And we'll learn about the rules now. Okay, but before we do that, let's take a little break. I'm going to say we're going to do a short break, guys. A very weird break as well. We're coming back at 15:52, and then we are going to jump into database normalization. Okay. And it's quite cool, right? Because you might think this database looks pretty good, but actually it's awful. And it's terrible for like some very obvious reasons after you know the rules. So that can be quite interesting. So yeah, we'll see that when we get back. I'm going to go grab a glass of water quick. See you just now. Cool. Whoops, I was muted. It's just saying that the weather is pretty miserable at the moment, but that hailstorm that they mentioned did not happen, which is interesting. I think there was like a weather warning or something. Okay. I do not think we're going to be able to cover database normalization in 40 minutes, unfortunately. Yeah. It is kind of drizzling outside, it looks like, at my house. I do like those really loud thunderstorms just before I'm going to sleep. It's pretty great. It's something you miss outside of South Africa, you know? Like they don't have that bad, like those really bad lightning storms, or I guess they're not bad, but you know what I mean. Cold or hot temperatures. I have to say, so usually I'd say cold, but this last winter was bad. Usually I'd say cold because it's easier to dress warmer, right, than it is to like cool down in super hot temperatures. And I think I'd really, really hate living in places where they have like those 40-degree temperatures and stuff. But yeah, I don't know. I think Joburg has pretty good weather. I'm pretty okay with Joburg's weather. Wouldn't want colder, wouldn't want warmer. What about you? Before we start. Okay, 50 seconds still. So we can afford to discuss the temperature. So we will get back to like the more relaxed time and scheduling at some point, but yeah, it's just currently with the game design course. Because it's really horrible when the lecture just cuts off. I can't say goodbye and stuff. But yeah, I do not think we're going to be able to finish all of them. Let me see. Okay, so third normal form database query. Maybe we can make it. The plan is to make like some online you prefer cold too. Cool, yeah, makes sense. Yeah, I'm thinking of making like some kind of online database that we can all query to learn about the stuff, but that could be a huge mission, but maybe there's some straightforward way to do it. We'll see. Updating data. But this section could be quite long, although the questions they ask at the end really don't justify some of the discussion. Anyway, so let's go. Cool. So normalization, pretty interesting. So why is this database that we created so awful? Well, it has to do with what we call data integrity. Okay, data integrity. And yeah, it makes sense as a term, I guess. Oh, but also ease of maintenance. Okay, so the reason we normalize databases is to protect data integrity and to improve the ease of maintenance. So like the how easy it is to maintain and update the database and the data in it. Okay, so in order to see why our database is so bad, we can actually just consider even one table. Okay, because there are 3 ways in which this database is insufficient. Okay, there are 3 reasons why it's bad. Now, all I did, so I took our book table and all I did was add a genre ID, okay? Just to emphasize that technically, like a book's genre is like the idea of a genre is kind of its own concept, right? It's its own entity. So and likewise, the idea of an author is kind of its own concept. It's its own entity, but we're going to focus on genre. So let's focus on genre. I think it's an easier one to wrap our heads around. So we'll see a number of reasons why this database is insufficient. So there are 3 different ways, okay, that we can confirm a database is not normalized. There are 3 different reasons why we normalize a database. They are what we call anomalies. Okay, there are 3 anomalies that can occur. So one anomaly is called an insert anomaly. Okay, so that means you can't insert new data into the database but due to an unrelated dependency. So here a very good example of this is, let's say, as an organization, so let's say we publish books or something. Okay, as an organization, we want to add another genre to our list of options. So we currently have poetry and fiction. Okay, you guys can see that on the right there. Okay, if I wanted to add another genre, like let's say historical, I wanted to add the historical genre. Yeah, exactly. Historical, yeah, exactly. So if we wanted to add a new genre, we would have to add a book with that genre. Okay, by the way, our current database is structured. And how we describe this is we have an unrelated dependency. So I kind of suggested that to you guys earlier as well, because you can see that the genre of a book is not directly related or dependent on the book itself. Like you might think as a human, right, you read a book, it's fiction or it's nonfiction, right? Like what is he talking about? But you can see that genres are a separate concept. They are functionally independent of the book itself, okay? Like we could have the genre of history without having historical books, if that makes sense. But yeah, exactly. How Adam put it is pretty good. If there isn't an entry for a whole row, then we can't add a new genre type. Precisely. That's called an insert anomaly. Why do we call it that? We want to insert data that should legitimately be inserted, right? Like, why don't we have other genres? Just because we only have 3 books so far doesn't mean we can only have these 2 different genres. So yeah, perfect sense. Okay, so that's one kind of anomaly, but I told you there were 3. Okay. The other kind of anomaly that can occur is a delete anomaly. So that is the deletion of one type of data causes the loss of other data. So let's say we went ahead and deleted the first book from our database. Okay, so the War Poems of Sigrid Sassoon, for some reason, we're no longer listing it on our website. What we've done now is we've lost the concept of poetry as a genre. Okay, so like if you asked me, so you can picture this in like a business, right? So let's say one day our boss comes to us and says, look, the War Poems of Sigrid Sassoon, we no longer sell it, delete it from the database. The next day, your boss comes to you and they ask, or let's say you're the boss, that's better. Because yeah. So the next day, you want to find out what genres have you had in your database since your company started. So what the problem is now is that technically you only have fiction in your database. Poetry no longer exists as a concept in this database since we deleted the War Poems of Sigrid Sassoon. Okay, so hopefully you guys can see all of this has to do kind of with the fact that genre is not directly related to book, or not functionally dependent on book. They are related, they're not functionally dependent. Okay, and we'll get into the definition of functional dependence later for those of you who, but I do just want to put the word in your brain, right? So it's like hovering around there. Okay, the last kind of anomaly that can occur is an update anomaly. So when updating a single data value requires updating multiple rows. Okay, so for example, if we decide that actually fiction is not a really good way of describing metamorphosis, it actually should be literary fiction. Okay, likewise, Grimm's fairy tales, probably not what you're expecting when you just buy a standard fiction title, right? Both of these should maybe be changed to something else. So let's say we want to try out changing them to literary fiction. When we change Franz Kafka's Metamorphosis to literary fiction, okay, so we change that item to literary fiction, you can see that it has a genre of ID 2. This also has a genre ID of 2. So this also needs to be updated to literary fiction. So we now have to update 2 rows in order to update this one thing, okay, this one concept. I just want to change fiction to literary fiction, and I now have to update multiple rows of my database. Now, this isn't so bad in this case, but you can imagine if you're managing a database with hundreds of thousands of books, this would be very inefficient and just annoying, okay, very annoying. Oh no, the rain is starting, which means you guys are not going to be, I won't even be able to hear myself soon. Okay, but let's see. We're gonna push through. I can just move to my room if worse comes to worse. Cool. Please just stay light for like just 10 more minutes, Rain. 20 more minutes. Okay. Cool. So when we normalize, it's actually pretty easy. So there's sort of a sequence of steps that you follow, or rather rules that we apply. Okay, we apply these rules, and there are 3 rules that we apply, and we call them forms because you're moving the database through various forms as you apply each of these rules. Okay, so there are 3 rules that we need to apply in order to fix all of these anomalies. So there will no longer be this problem of inserting new stuff or deleting new stuff or updating new stuff. Now, remember, guys, this is one example, this idea of books and publishers. There is another example in your book. So if you want to see another group of examples of how we normalize a database, there's another one in your book, and I've got a new, like a different one here. Okay, cool. So there are 3 rules. We call them the normal forms. Why normal? Because they're normalizing the database. And like this is how we denote them. So this is the first normal form. It's like the first rule that we consider in order to correct all of those anomalies that can occur in a newly created database. Okay. And you can see that even though this database looked okay, even just this table is very wrong, right? Very wrong. And without these rules, it would be difficult to pin down exactly why. Okay, and there can be serious problems with your database, even if it looks fine to like just a standard, eyeballing it. Okay. So these rules are usually fairly simple, actually. So for a table to be in the first normal form, so this is like the first rule, for a table to be in the first normal form, none of its columns should contain multiple values. Okay, that's a pretty easy first rule. Okay, so we can look at our database here. Are we in first normal form? The answer, it requires you to read very carefully. I think if you don't know that, I can give a little hint. Grimm's fairy tales, yeah, it's not. The reason it's not is because Grimm's fairy tales has two authors. I don't know if you guys know this. They're the brothers Grimm, right? Jacob Grimm and Wilhelm Grimm. They wrote Grimm's fairy tales together. Okay, so this here is a problem. Because if you want to maybe update one of their names, or you want to add pronunciation to it, or just any old thing, it's really bad that two values are contained in one field. Okay, so there we go. This is not in first normal form. It's pretty easy to change this to first normal form. We can just sort of drop author from the database, and we add this. Okay. So what did I just do? This is basically exactly what we did with publishers and books. In fact, we just created a relation. So you can see what I did. This author column, I go, okay, this author column is causing trouble because there's two values. This means this table is not in first normal form. So I'm just going to remove this column, and I'm going to put all the authors in another table. Okay, all of the authors will go in another table. And then I'll just relate books to authors the same way I related publishers to books. Okay, so we'll be able to see that now. So I drop author from the table. So author's just gone. It's now just ID, title, genre, ID, and genre. And we open up a new table on the right here. And you can see our problem is solved. Okay, so because now we have book ID relating to authors. So if I want to find which author wrote Grimm's fairy tales, I can go to the author table, which is over here, and I just look for every single author that has a book ID of 3. Okay. Actually, this table on the right here is very wrong. You need an ID as well for the authors, because there's no primary key in this table. Sorry about that, guys. I'll update it for when you're studying from the slides. But you can understand the relation. Picture, there's also an ID for each author. Okay, an ID for each author. Okay. But yeah, sorry about that. Constructing your own example can get a bit hairy sometimes. Okay, cool. But anyway, so you can see we can map, essentially we're mapping books to authors. There is a problem with this database, as I just said. The issue is that authors currently don't have a primary key, but you could add one quite easily. Author ID, right? Just like we have on the left here, 1, 2, and 3. We would just have 1, 2, 3, 4. Okay, cool. But that would then put this table over here, this table on the left, would be in first normal form. Okay, because it no longer has this problem of a single column having multiple values. Now, it's quite easy to see when a column holds multiple values, or when a field is holding multiple values. Okay, it usually means that there's going to be something separated with a comma. So you can see that here, Jacob Grimm, comma, Wilhelm Grimm. There's clearly 2 names there. There's 2 authors there, and that's an issue. You need to split that up. Okay, or then you'll have update anomalies and insert anomalies and all of that kind of thing. Okay, cool. So that's the first normal form. It's not a bad one. And again, if you remember the rule, it's easy to fix. Okay, easy to fix. Okay. Now, in order to discuss second normal form, we have to learn a couple of new concepts, actually. So first normal form is easy. You just need to check if a column contains multiple values. Second normal form requires some extra understanding. Number 1, I mentioned this idea of functional dependence. That's the first thing that we really need to nail down. Okay, so this is a fairly mathematical definition. Not all Like in your book, they don't even provide, in my eyes, they only provide an example of functional dependence. They don't provide a definition. This is a good working definition. So if you're ever in a pinch, you can use this and you'll come out okay. Okay. But it's a good thing to sort of get now is that this whole database design thing really does rely at least somewhat on your intuition. Okay. Because you can see like over here, when you say, what does it mean for a column to contain multiple values? So here I gave you a fairly obvious example, but you can see that there could be cases where a little bit of intuition is required. Like let's say title also had a like one of the books also had a subtitle. That might be okay. Okay, that could be okay in certain circumstances. It would rely on your intuition of what you're using the database for. And I wanted to expose you to that with that simple example, because in functional dependence, it can get a little bit more fuzzy. Okay, but I'll show you now here with some nice like pictures and stuff, so that you can sort of see what I'm describing. So what do we mean by functional dependence? Okay, so y being functionally dependent on x means that the value of x uniquely determines the value of y. Now, the word uniquely is important there, guys. The word uniquely is important there. And then also your understanding of the word determines probably needs to be updated. Okay. So let's see what we mean by this. The ID over here. Okay. So for each ID, right, you can uniquely determine the title of the book. Okay. The ID determines the title of the book. Okay. So we would call that functional dependence, uniquely determines. If you say 1, the title is The War Poems of Sigrid Sassoon. No other ID will also point to that title. That's important because it needs to uniquely determine. Okay. And likewise, there can't be another ID of type 1. Okay. There's only one. Okay. Or only 2, only 3. Okay. Like only one of them. All right. And it needs to uniquely determine. So how can we see this problem of the importance of the word uniquely? So we can see, actually, if we know the ID of the book, we can determine, okay, we can determine its genre, right? Like if you know the ID of the book is 1, you know the genre is poetry. You can determine that the genre is poetry. If you know the ID of the book is 2, you can determine that the genre is fiction. If you know the ID of the book is 3, you can determine that the genre is also fiction. Okay. So the important thing here is that the ID is uniquely identifying each record. But the thing is, this word uniquely, it's saying uniquely determines the value of y. So why is this? So let's see. So we've got this concept of functional. Oh, sorry, annotations are opens. That's why I couldn't click. Okay. So it's interesting to see the word uniquely is what's stopping genre from being functionally dependent on ID. Okay. The reason for that is because genre is not uniquely determined by ID. It is determined by ID, right? Like if the ID is 3, you can determine the genre is fiction, but it is not uniquely determined because ID 2 and ID 3 have a genre of fiction. Okay. Now you might say, but sir, is it not possible for 2 different books to have the same title? And the answer is yes. Okay, it is. But you know, we can't, nothing is perfect. Okay, so that's why I say it does rely on your intuition a little bit. You must trust your instinct on this. Okay. But in this case, we can see, like by this, even this definition at the top here, fiction appears twice for 2 different IDs. So the ID is not uniquely determining the genre, which means that they are not functionally dependent. Okay. What is functionally dependent? Genre ID or genre is functionally dependent on genre ID. Okay. Because the genre ID uniquely determines the genre. If you know the ID is 2, you know the genre is fiction. Okay. and vice versa. If you know the genre is fiction, you know the genre ID is 2. And actually, that's a good way of thinking about it. If I tell you that the genre is fiction, what does that tell you about the ID of the book? Nothing, right? You don't know. Is the ID 2 or is the ID 3? You don't know. Okay, because it's not uniquely determining. Okay, so functionally dependent means that it uniquely determines the value of the other thing. Okay. Hopefully that makes sense. I know it is, and it is fuzzy. Don't worry. Like when I was learning this back in high school IT, I was also like, but what about all of these weird cases? And it is like database design. It is relying somewhat on your intuition of like what the database is being used for and what kind of data will be stored there. Okay. It does. Like these definitions are not perfect because there are definitely cases of 2 different books having the same title. But for the sake of convenience, we would definitely say, unique. Okay. Anyway, so that's the concept of functional dependence. And you can see that it's somewhat related to this idea of like the key as well. So what we've been glossing over for now is that each of our rows have had this ID. And the ID is just uniquely identifying each row. Okay. Like the ID over here is just uniquely identifying each book. So 1, 2, 3. And you can see it's underlined. That's called a primary key. It is possible for you to have more than one primary key, more than one column in your primary key. Okay, and we call those composite keys. So over here, I've got a table called animal sightings. Okay, so each row of this table is an animal sighting. Okay, they have a date and they have a name. All right, so you can see that to uniquely identify each row, you need to know both the ID of the animal sighting and the ID of the animal. Okay, like I couldn't just give you I couldn't just give you one is the essential thing. Okay, because the animal name is here. Okay, we'll expand on this a little bit because it is just somewhat definitive. Like it's just me saying, because you see they're both underlined. So there are multiple columns in my primary key. Okay, so you can see that each sighting has a date and each sighting has an animal. Okay, but you see the same animal appears multiple times and the same date could also appear multiple times. Okay, so while I agree you could create a different ID for each record, we're saying definitively here. Okay, definitively, and you'll see why in a little bit. We'll split things up in a little bit. Okay. But anyway, so you can see that there was a sighting on, what is that, the 28th of September of a rhino, a sighting on the 30th of September of an elephant, and a sighting on the 5th of October of a rhino again. Okay. Each row has its ID, and it also stores the animal ID of the animal it was sighting. Okay, I can also tell you, so this is one example. You can see a similar example in your book as well on page 148, somewhat similar. Okay. So why do we call this a composite key? Because there are multiple items in our primary key, okay, multiple columns in our primary key rather, or multiple attributes in our primary key. Okay. And yeah, so it's important to understand both functional dependence and composite keys before you understand second normal form. And what's nice about this though, is that once you know those 2 things, second normal form is very easy to understand. So if you read the actual definition by itself, it could look quite complicated. So let's see. For a table to be in 2NF, it must be in 1NF. Okay, so number 1, for it to be in 1NF, it mustn't have multiple values in any of its rows, in any of its columns, I mean, or in any field. There must not be multiple values in any field or any column. Okay, so if it's in 1NF, then it might be in 2NF, but there's another part of the rule. So this is the second rule. All non-key columns must be functionally dependent on the entire primary key. Okay, so it seems pretty confusing, but let's look at an example. Okay, so what's nice about this rule? What's nice about this rule is that any table that only has one column in its primary key and is in 1NF will automatically be in 2NF. Okay, so all tables with a single column as their key. So what do I mean by that? If we look at our book table over here, we have the ID. The ID is what we have defined as uniquely identifying each row. Okay. Cool. And we can see, so let me also just jump to like a new, okay. With our animal citing, we have not made that definition. Okay. So yeah, cool. So here we have the animal citing. Okay, so for the ID and animal ID, we have a composite key. Okay, to uniquely identify each row, we need both IDs. Okay, this means that this might not be in 2NF. Okay, and the reason it's not in 2NF is because the animal name is not functionally dependent on the ID. Okay, similar to how it was in our book, in our book case. Okay, but again, the fact is that this was defined with the composite key. Okay, composite key. So ID. Okay. So the animal name is not uniquely determined by the ID in the first place. They're not functionally dependent. They're not functionally dependent. And notice, it says entire primary key. Entire primary key. So if we look back at this previous table, okay, it doesn't matter that genre is not functionally dependent on ID itself. I'll explain it with animal citing because it'll be easier to get across. Okay, you can see that the animal name is not functionally dependent on the entire primary key. It's only functionally dependent on animal ID. Okay, you see that? It's only functionally dependent on animal ID. And animal ID is a part of the primary key. Okay, but the thing is, the other part of the primary key is the ID itself. Okay, that's there, the ID. Okay, so animal name is not functionally dependent on the entire primary key. It's only functionally dependent on a part of the primary key, which is why we say if it is functionally dependent on the entire primary key, then it'll automatically be in 2NF. So if it only has one column in its primary key, then it will be in 2NF. Okay. Cool. So an easy way to ensure that it is in 2NF is actually just to remove the item that is not functionally dependent. Okay. So essentially, there's two ways of doing this. You could either say that animal ID is no longer a part of the primary key, or just remove animal ID. Or you could say that animal name must just be removed. Okay, and we'll relate animal ID to that other table afterwards. Okay, now you can see this wouldn't solve all the problems we have with functional dependence. That's what the third normal form is for. Okay, but you can see that this is a good solution because now animal ID is functionally dependent on ID and date is functionally dependent on ID. Okay, cool. Okay, let's move forward. Let me see, how much time do we have left? We should conclude soon. Okay, so I'll go through this now. Okay, so for a table to be in 3NF, it must be in 2NF. So that is to say, either it just mustn't have a composite key, or if it does have a composite key, everything in the table must be determined on the entire key, must be functionally dependent on the entire key. And there must be no functional dependence between non-key attributes. And so for those of you who are wondering, like in our last little discussion with the entire primary key thing, it might have confused a bit about second normal form. But third normal form makes it sensible again. Okay, it makes it make sense again. And you'll see why now. Because you can see this, it doesn't, like the definition of functional dependence is almost inconsistent with this idea of the entire primary key. Okay, but here that question is answered because you can see that it says there must be no functional dependence between non-key attributes. Okay, so let me jump back quickly. So you can see that here in our book, so here we can uniquely identify. So if you know the ID, you can uniquely determine everything about the book. Okay. However, we have seen that there is functional dependence here. But because genre ID is not in the primary key, it doesn't matter. Okay. It doesn't matter. The only reason it mattered with the animal sighting example is because the animal ID was in the primary key. Okay, it was in the primary key. So I'll expand with the next slide. You'll see how this corrects our issue. So now the rule is for 3NF, after you've corrected this problem of having a composite, everything being dependent on the entire primary key, you now have to answer this question. There must be no functional dependence between non-key attributes. Okay, so what do we mean by that? Genre ID, as we mentioned long ago when discussing functional dependence, is that genre is functionally dependent on genre ID. But book ID is the primary key. It's what's uniquely identifying each row. So this violates the third normal form. And this only is where we correct all of the problems with the anomalies that we were discussing earlier. Only after going through the entire process of normalization do we finally fix this problem of fiction being updated when we don't want it to be, okay, or deleted when we don't want it to be. So let me show you that now. So you can see that genre is functionally dependent on genre ID, but genre ID is a non-key attribute. Okay, it has shrinked a lot, and you'll see it'll shrink even more. So you can see this will actually be our book table, and that will be our genre table. Okay, and that will put it into 3NF. And you end up with a ridiculous number of just tiny tables. Okay. So now you can see what is the benefit here. If I want to update the name of this genre, if I want to update this to literary fiction, you can see that it's now not a problem. I can just update it. And then all of the books, the book table doesn't have to change at all. Okay. I update one row, the book table doesn't have to change at all. If I want to update the name of poetry, same thing. The book table doesn't have to change at all. Okay. So this is how you would actually design that database. Okay. So it looks very different from what it looked like after we had just finished our ERD, our entity relation. That's better than having a huge, yeah, definitely better than having a huge table with all the anomalies. And yeah, so the splitting, it can be confusing defining how you can split, but each normal form in and of itself, just remember the rule for each normal form. Okay, just remember the rule for each normal form, and then it's easy to remember how exactly to do it or to determine how to do it. Okay, so no column should contain multiple values. That's 1NF. 2NF, it must be in 1NF, and all columns should be functionally dependent on the entire primary key. A little trick you can remember there. If you've only got one column in your primary key, it's already in 2NF. You don't have to look at it more. Okay. This rule only needs to be considered when you have a composite key, more than one key. Okay. More than one column in your function, in your key. And 3NF, it must be in 2NF, which means it also must be in 1NF, right? Because in order for it to be in 2NF, it had to be in 1NF. So like the next form always implies the previous form. And there must be no functional dependence between non-key attributes. So now you have to look at all of the other columns, like genre ID. Even though it's not in the primary key, genre is functionally dependent on genre ID. So you have to fix that. Now, you didn't have to fix it in the previous step because genre ID was not a part of the primary key. Okay, so the keyword, so 3 has to be in 2, has to be in 1. Yeah, precisely. And the keyword for 2NF is this entire primary key thing, the entire primary key. So yeah, it becomes, again, it's a little bit confusing. I know I don't know, my words were getting twisted with 2NF, but hopefully once you see 3NF, it ties together, okay? It should all tie together. But yeah, that's normalization. Those are the 3 normal forms. at least as taught. I know. So again, IT students, there are different ways of describing this rule. You might have heard it in IT as being no transitive dependence on the primary key, okay? But they mean the same thing, all right? But do remember like both ways of saying it, because yeah, you can't just rely on the one. But this is an easier way to define it as well, because you only have to define functional dependence. Anyway, yeah, we are going to stop there. Oh, guys, please do the chapter 5 knowledge assessments this week. And like the chapter 4 one, I'll send you the solutions for the chapter 5 one like next week. Okay. So the chapter 5 knowledge assessments is on page 138. But other than that, we are done for the day. I'll figure out how to get you guys a more practical example of SQL, at least somehow. We might do it theory in the lecture and then give you guys some like practical assessments or like some kind of project or something. I don't know how we'll do it, but it would be fun if we could like edit the same database live. That's what I'm trying to think of doing, but that could be a nightmare to set up, but we'll see. And we know that we're going to get trolls just deleting the whole table or something. But I don't know. I'll see what to do. But anyway, yeah, we'll probably be cut off soon. Yeah, you too, Alex. Enjoy. You too, Tanya. Cheers, guys. Thank you for coming.
So have a good weekend. Thank you.
You too, Amilcar. Cheers.
Thank you, sir.
Thank you, Liama. Sorry, I wanted to say, do tell me. So the reason I couldn't postpone is because we're going to be cut off at 4:30 because the game design course will start. But next week, there'll be no more game design. So always tell me if there's going to be like school conflicts or something, because next week we can be more flexible with the time. Okay.
Okay, sir. Thank you.
Cool. Yeah, thank you. Cheers.